Hello everyone, welcome to my video. I am Dr. Albert Jiang at the University of Waterloo with the Department of Systems and Design Engineering. This video series is a companion learning material designed for MTE182 Dynamics. They are optional and will always be available at any time to everyone. As for the reason behind this and my motivations, I will talk about that in a moment. This is considered the first lecture, and there are 25 videos in total. In this video, we will start with Chapter 1, covering sections 1.1 to 1.4. For those students in my class, you can find copies of these video slides on Learn, and they are available to you. So, welcome to Dynamics. What does the word dynamics mean to you? How much do you recall from your high school physics? And when you are thinking about it, what concepts, what scenario, what examples comes to you? So the motivation behind this, the most frequent or number one feedback from students in the past who took this course is, please do more examples. So my motivation of making those videos is simple. I want to spend the in-person lecture time with you to do more examples with you. Then the behind-the-scene part, which is how those equations were derived and some basic concepts are being explained in these videos. So I try to make those videos short and concise, and I can guarantee you if you watch those videos before each class, you will learn more effectively. So before we start, there are some unspoken concepts that I assume you know before entering this class or before watching those videos. The mathematics perspective, geometry, algebra, vectors, differentiation, and integration. If you're not familiar with any of those concepts or need a review, your textbook appendices has a brief review of those concepts. You also took Physics 1 statics before this semester, so you should be familiar with free body diagram, force summation, support and reaction forces, friction, and moment. So you have learned statics. That's why you're here now. In statics, we deal with objects that are not moving, or say at least nearly still. In dynamics, we are going to deal with moving objects or moving rigid bodies. That is when the velocity is not zero. There are two core components in dynamics, kinematics and kinetics. One focuses on the motion itself. Just look at how it moves, and we do not really care about why it moves, and that's kinematics. On the other hand, kinetics focus on why it moves and what is causing the movement. Is it gravity, is it friction, or any other forces? There are some basic concepts, or I like to call them as keywords, you should be super familiar with. I like to use this diagram to illustrate. It's a plane here. So in general, we have a space that we can use it to set up reference. So for example, the plane here can report its coordinates back to the ATC. This is called reference or coordinates. With a space, there is a time, which we can use it to measure the succession of events, such as how long does it take for the plane to move from A to B. And the plane has a payload, say 30 tons. This is mass. It is the property to the project itself which won't change with motion or time. At the same time, since all objects are subject to gravity, there is a weight of the object. This is a force. Because of its a force, the plane engine has to provide enough power to overcome the weight to be able to fly. And when we are considering flying from A to B, since the overall distance of interest is so long, the relative size of the plane becomes less of interest. So it can be treated as a particle while we are interested in its overall flight path. Also, when we are looking at the overall flight route, the plane can be treated as a rigid body which has no changes in its shape. So here's a summary of those keywords we just talked about. Beyond that, taking a step back, there are two types of variables we will be dealing with, scalar and vector. So scalar is a quantity without direction, and vector is a quantity with direction, such as mass, speed, distance. They are scalar. They do not have a direction. And vector, there's a weight, velocity, and displacement. I hope you notice I on purposely put mass and weight here, speed and velocity here, and distance and displacement here. They are the scalar and vector counterpart of each other. So make sure you understand which is scalar and what is vector. So I hope you are familiar with these three Newton's laws. Law 1 deals with a uniform velocity, Law 2 deals with acceleration, and Law 3 deals with opposite forces. In this course, Law 2 is the most important one we'll be dealing with throughout the entire semester. So let's take a look at this in detail. Since we're just talking about vector and scalar, F equals to ma is the governing equation behind Law 2, and this will be used throughout the entire semester. One is scalar, force is scalar, acceleration is scalar. Just keep that in mind. They have directions. So far, we're just mostly reviewing. Okay, so hopefully none of those concepts were not too unfamiliar to you or too hard to you to understand. I like to take a moment to review free body diagram. I know you probably already have a very good way to draw a free body diagram without making any mistake or missing any forces. That's fine. You don't need to follow my instructions. You can use your own way in the exam, in your assignment. It doesn't matter. Here, I just want to provide a reference or a quick review about how I would draw a free body diagram without missing anything. And hopefully this is somewhat useful to you or somewhat a complement to what you already know. I like to call this the GNEF method. Let's use a very simple movement here, the pushing a box uphill. The moving direction is uphill. Don't worry about those numbers on the diagram. We don't need that. We just need to know how to draw the free body diagram. How does the GNEF method works is number one, there must be the gravity. Okay? No matter what happens, the gravity will be there. That's G, gravity. Number two, contacting surface gives a normal force. As long as you're contacting somewhere, there will be a normal force. So that's N. Step three, any external forces will have to be drawn at this point. Right? The external, that gives you the E. So what is external forces? What are considered external forces? So here I say other than G and F, other than gravity, other than normal force, and other than friction. Because friction is our number 4, F, we'll analyze friction. Because with the gravity, normal, and external forces drawn, we will be able to analyze according to the moving direction, where does the friction go? Is the friction going with the moving direction? Is the friction going with the moving direction? It really depends on how the contacting surface works. Right? Sometimes you will have friction in the same direction with the moving direction, but most of the time the friction will go against the moving direction. So this I would like to call the GNEF method. I will be using this method throughout the entire semester whenever I need to do a free body diagram, and you will see that multiple times in my demonstrations. Section 1.4, units. Of course, different variables have different units and dimensions. I'm not going to spend too much time on this. You already know this very well. Just recall from what you learned before, units can be calculated. You can add, subtract, multiply, and divide. That's how unit conversion is done, and that's why you can cancel out some units. We'll be using both imperial and metric units. If I have to make one reminder about units, then that would be please pay attention to the mass unit. the imperial unit of mass is slug, not pounds. Just a very friendly reminder. You will appreciate it. Once again, as I said, I want to make those videos short, simple, and concise. Welcome to Dynamics. Welcome to the course. I hope you can utilize this series of video to improve your learning experience. Again, they are here. Watch them at any time, anywhere, and as many times as you like. If you have questions, please leave it in the comment below. Or if you are in my class, just reach out to me directly. Thanks for watching. I'll see you next time.